Hi there. In this video, we're going to talk about solving systems of equations in three variables. The rule of thumb with systems of equations is however many unknowns or variables you have, that's the number of equations you need to solve them. So if I have two unknowns, like x and y, then I need two equations to solve the system. If I have three unknowns, x, y, and z, I need three equations to solve the system. And if I had four unknowns, I would need four equations, and so on. Usually, when you get beyond three or four unknowns, you turn to other methods, such as matrices, to solve those. But if it's about three variables, then it's usually worth it to just use addition or substitution methods that we learned in the previous section. So today we're going to use the addition method to solve a system of three equations with three unknowns. Now, on the test, I'll be asking you to use the addition method as well, so I would stick to that one for the most part when solving systems of three unknowns. So the trick here is when you're starting out, you have to make a decision on what variable you're going to eliminate first. And you're going to have to stick with that for the rest of the problem. So I'm going to start out using the addition method, adding two of the equations together to eliminate a variable. Whatever variable I pick, I'm going to have to repeat that process with a different pair of the two equations and eliminate the same variable. So if I, for instance, look at this and say, I'm going to eliminate the x's by adding the first two equations, then I would go and eliminate the x's again by adding a different pair of these three equations. So you have to pick, okay? So as long as you're consistent with those first two, then you'll be fine. What this will result in is a system of two equations with the same two unknowns that we can then solve just like we did in the last section. So for this one, I have to make a decision. There is no wrong choice here, but just know that your work might look different from someone else's if you chose a different variable to eliminate from the onset. Now, I kind of gravitate towards eliminating the y's here because the second and third equation both have a 2y, one negative, one positive. So if I just add the second and third equation to each other, I will already eliminate a variable without having to multiply either equation by anything. So that's what I'm going to do. I'm going to take the second and third equation and add them together. So x minus 2y minus 2z equals negative 1, plus 4x plus 2y plus 6z equals 2. X plus 4x gives me a 5x. The y's cancel out, and negative 2z plus 6z equals 4z. On the right side of the equations, negative 1 plus 2 gives me 1. So I've gone down to an equation with just an x and a z in it. Now I want to pick a different pair of equations, eliminate the same variable, so that I get another equation with just an x and a z in it. And then I'll solve that system. So looking at this, I think if I just multiply that second equation by negative 2, then the y term will become positive 4y and will cancel with the negative 4y from the first equation. So I'm going to multiply that equation by negative 2. It gives me negative 2x plus 4y plus 4z equals 2. Be very careful with the details on this. You'll be ripping your hair out trying to figure out where you went wrong if you don't multiply these correctly. And then I add that to the first equation, 4x minus 4y plus 4z equals negative 8. So negative 2x plus 4x gives me 2x. The y's cancel, and 4z plus 4z equals 8z. Then on the right side of the equations, 2 minus 8 equals negative 6. Okay, so now I have equation 4 and an equation 5, two new equations that I can use to solve the system. They have just x and z's in them. I'm going to continue using the addition method. So I'm going to multiply one or both of these equations by something to eliminate another variable. And in this case, I notice I've got a 4z and an 8z. If I just multiply the 5x plus 4z equals 1 times negative 2, then I'll get some z terms that will cancel out when I add the equations. So multiplying that by negative 2 gives me negative 10x minus 8z equals negative 2. And I'm going to add that to the 2x plus 8z equals negative 6. Okay, so adding those, negative 10x plus 2x gives me negative 8x. The z's cancel, and negative 2 minus 6 minus minus 6 gives me negative 8. So negative 8x equals negative 8. Dividing that by negative 8 gives me my first solution, x equals 1. It's a lot of work to get that first number, but it goes much more quickly once you do. So most work and effort goes into finding that first part of the solution, and then I can just start back solving, plugging this into previous equations to solve for the other missing variables. Since I just have the x, I'm going to go back to equations 4 and 5 and plug it into one of those so I can solve for z. So I'm going to pick the first one I got, 5x plus 4z equals 1, and I plug in x equals 1. So that's 5 plus 4z equals 1. If I subtract the 4 over, I get 4z equals negative 4. And then divide by 4 to get z equals negative 1. So that's 2 solutions down, 1 to go. I still need to find the y. So I have to go back to an equation that has a y in it, which is one of the original 3. Pick any one of those, plug in your x and z, and solve for the last variable. So I picked the middle one. It was the simplest one, smallest numbers in it. So I get 1 minus 2y minus 2 times negative 1 equals negative 1. And if I clean up the variables on the left or the constants, I get negative 2y plus 3 equals negative 1. And then subtract 3 to get negative 2y equals negative 4. And divide by negative 2 to get my final solution, y equals 2. Putting that into an ordered triple for my final answer, I get 1, 2, negative 1 for my solution.